Hi guys, this is our third lecture that we'll be doing, and tonight we're going to be talking about memory storage. In other words, how do we keep the memories once we've made them? Where do they go? So, we'll start off talking about capacity and location. How much can the brain hold, and where does it hold this? So to start out, I know I've been comparing the brain a lot to a computer or a hard drive on the computer, but memories are not isolated files. The brain is not a machine. Instead, rather than isolated files, these memories kind of overlap and intermingle with different neural networks. So we'll explain this more as we go on. The brain's long-term memory storage doesn't get full. It's unlimited. It gets more elaborately rewired and interconnected the more you learn. So there's no way that you have to format your hard drive eventually because you have too much stuff. It's not like that. It's potentially unlimited. And parts of each memory can be distributed throughout the brain. So there's no central storehouse for memories. Different types of memories are stored in different parts of the brain, as we'll see. So, for example, the memory of a particular kitchen table, the one that I'm sitting at now, in my mind it may be connected and linked to a network containing the ideas or the concepts kitchen, sit, meal, wooden, legs, maybe the Kmart that I bought this table at for $150. It's a nice table. But anyway, all these ideas and all these memories are interconnected and are located and distributed throughout the brain, not just one central storehouse. So we know this because this guy, Carl Lashley, did some experiments on some lab rats, which, raises ethical concerns. However, this was back in the 40s and 50s. He showed that rats who had learned a maze retained parts of that memory even when small parts of their brains were removed. So this shows that the brain, or the memories aren't located in one part of the brain, but that they're distributed throughout. So how does the brain process memories? We talked about this a bit, but we'll talk about exactly where certain memories are processed now. So if memory is stored throughout the brain, how does it get in there, and how do we retrieve it and use it? So there's different storage and retrieval/activation systems in the brain for explicit memories or declarative memories and implicit or procedural memories. We talked about this in the other lecture. So when emotions become involved, yet another part of the brain can mark or flag some memories for quicker retrieval. So as I said, different types of memories are stored in different parts of the brain. And the storage occurs by changing how neurons link to each other in order to make some well-used neural networks of neurons easier to activate together. So the part of the brain that you're accessing all the time, for example, some of your friends, when you meet them, that part of the brain that recognizes them, it's easily accessed because you use it all the time. So how do explicit memories get processed? Remember, explicit or declarative memories, these include facts that you know, stories that you remember, meanings of words, and such as the first time riding a bike, you remember doing that, and facts about types of bicycles. These are all conscious memories, meaning you're aware of them, and you're aware of when they formed. Retrieval and use of explicit memories, which is in part a working memory or an executive function, as we explained in the last lecture, this is directed by the frontal lobes. So whenever you access a memory, you're actually accessing it from your frontal lobes. But the encoding and storage of explicit memories is facilitated by the hippocampus. As you can see there, these little spindly looking things, that's the hippocampus. This is where explicit memories are encoded and stored. So events and facts are held there for a couple of days before consolidating, which means they move to other parts of the brain for long-term storage. Much of this consolidation occurs during sleep. So when you're sleeping, all of the memories of the day are filed away neatly in some sort of long-term storage. So now how do implicit memories get processed? A little different than explicit memories. So remember, implicit memories include skills, procedures, and conditioned associations, all of which are unconscious. So when you smell something and it triggers the memory of a certain place or a certain moment, but you're unaware of it, that's an implicit memory. These are all unconscious memories. So we'll be talking about the basal ganglia and the cerebellum here. The cerebellum, or the little brain, Forms and stores are conditioned responses. So when we act sort of instinctively or reactively, this is coming from the cerebellum. And we could store a phobic response even if we can't recall how we acquired the fear. Oftentimes when we have a phobia, we have no idea how it formed. And so the basal ganglia, next to the thalamus, as you can see, controls movement and forms and stores procedural memories and motor skills. So we can learn to ride a bike even if we can't recall having the lesson. These are stored in the basal ganglia. And again, they're unconscious. If we can't remember learning to ride a bike, yet we still can, that means these are implicit memories. How does emotions play into memory? Because as we talked about a little bit, emotions definitely have an effect on how memories are experienced and stored. So remember we talked about 9/11 and how this was a flashbulb memory, meaning the emotions kind of sear it into your brain. Strong emotions, especially stress, can strengthen memory formation. As we talked about, flashbulb memories refers to the emotionally intense events that become burned in your consciousness as a vivid seeming memory. You can recall it and it probably seems almost as vivid as when you experienced it. However, flashbulb memories tend not to be as accurate as they feel. Again, when we access memories, we're not accessing that moment, we're accessing a memory of that moment. So the state that we're in while we're accessing them sort of corrupts or influences the memory in that moment. So vividly storing information about dangers, this may have had some evolutionary advantage for ancestors and helped them survive. So in the wild, if they remember this one crazy time when the saber-toothed tiger came and almost killed him, but he did this certain thing that saved him, it would be in his best interest to memorize that moment as vividly as possible so that he could pass it on to the rest of his tribe. So emotions and stress hormones, the amygdala, and memory. How does this all work? How does intense emotion cause the brain to form intense memories? What goes on when we're experiencing these intense emotions, and how does it affect memory? So number one, first off, emotion can trigger a rise in stress hormones. We all know this. And these hormones in turn trigger activity in the amygdala, which is located next to the memory-forming hippocampus. So, the amygdala increases memory-forming activity and engages the frontal lobe and basal ganglia to tag the memories as important. I realize that's cut off down there, but it says that it tags the memories as important. So, as a result, the memories are stored with more sensory and emotional details. They're seared into our brain. These details can trigger a rapid, unintended recall of the memory. And as we'll see as the semester goes on, traumatized people can have intrusive recall that is so vivid that it feels like re-experiencing the event. So now we have this thing called long-term potentiation. This is LTP. So chemicals and shocks that prevent this process of long-term potentiation can prevent learning and even erase recent learning. So we've seen that preventing LTP keeps new memories from consolidating into long-term memories. For example, mice forget how to run a maze when this process occurs. And drugs that boost LTP help mice learn a maze more quickly and with fewer mistakes. So basically what LTP is the way that neurons are able to connect to one another. Certain chemicals and shocks prevent this from happening, which inhibits learning or keeps it from happening, and then certain experiences and drugs or chemicals make it happen more rapidly or facilitate it. Alright? So just to sum up, here's a little chart of the types of memory processing. So of course we have automatic and effortful, or implicit and explicit. So as we said, implicit is without conscious recall, explicit is with conscious recall. So these implicit memories are processed, as we said, by the cerebellum and basal ganglia. This is important to remember. And these are things like space, time, and frequency, all these sort of implicit things that we take for granted and don't think about ever. Things like motor skills and cognitive skills, things that aren't conscious. Again, classical conditioning, these sort of phobias and results of our childhood. On the other side, these explicit memories are processed in the hippocampus and the frontal lobes. And again, these are facts and general knowledge, for example, this chapter's context, and personally experienced events. So, there you have it. Study this map because it will be important. Have a good night. We'll see you tomorrow. Bye.